All right, this is a continuation. I've just drawn pictures for you of different states of matter, and you're going to have to learn to recognize those pictures, and I think I'm going to have you draw some. I'm not sure yet. Now, matter is not only classified by the state or phase, solid, liquid, gas, or plasma, but it's also classified by its state of purity, how pure it is. So there's two kinds of matter in terms of purity. There are mixtures and there are pure substances. There's a similar diagram like this in your textbook, but this is the diagram that I will be quizzing you on. Matter, it can be in mixtures or it can be pure. Now, if the matter is in mixtures, there are two kinds of mixtures. There are heterogeneous mixtures, and there are homogeneous mixtures. And if you have a homogeneous mixture, there can be solutions and there can be colloids. Okay, now some textbooks classify colloids as homogeneous mixtures, but some textbooks classify colloids as heterogeneous mixtures. For this Chem 65 class, please note that a colloid will be considered a homogeneous mixture. That would be the right answer. If you write down heterogeneous mixture for a colloid, I'm going to mark that wrong, okay? So this is something that is different in different textbooks, but for this class, please make sure that you know a colloid is a homogeneous mixture for this class. Now, among the pure substances, there are pure elements and there are pure compounds. All right, so let me show you what I mean by a pure element. Another picture for you to draw. Here's a gas, which is a pure element. See, there's only one kind of atom here, this white circle atom. Here's a gas, which is a pure compound. There's only one kind of, well, there are two kinds of atoms here, but only one kind of group of atoms, or molecule. So this is a molecule, this is a molecule, this is a molecule. These molecules are all a pure compound, meaning there's only one kind of molecule. Each molecule is made of two different kinds of atoms. These molecules, they could be all made of 3 atoms, but if you want it to be a pure compound, they all have to be the same 3 atoms, like that. I mean, each one of these molecules has to be the same. A black and 2 whites, a black and 2 whites, a black and 2 whites. That would be a compound. Now, what about a solution, which is a mixture? A solution can be a gas, liquid, or a solid. When the solution is a gas or a liquid, the solution is transparent. You could see right through it. Air is an example, well, the air in your room right now is an example of a solution, which is a gas. There is oxygen gas. There is nitrogen gas. There is, let me put some more oxygen gas. There is some carbon dioxide gas. There is some water gas. Okay, so a solution means that there are no clumps of molecules. All the molecules are evenly spread out throughout the container. That is a solution. Also, you do not have just one kind of molecule, such as in the compound. You do not just have one kind of atom, such as in the element. But you have 2 or more. So in this case, I have several different kinds of molecules here. But you see, those molecules are all evenly spread out. On the top here, I have some carbon dioxide, some nitrogen, some oxygen. On the bottom, I have the same thing, carbon dioxide, nitrogen, oxygen. On the left side, I have some carbon dioxide, nitrogen, oxygen. On the right side, I have carbon dioxide, nitrogen, oxygen. So we're all evenly spread out. That's a solution. Let me give you something different. A colloid. You can't see through a colloid. I mean, if you see through it, it would be foggy, translucent, rather than transparent. It would be blurry or cloudy. Milk is an example of a colloid. Let me show you what milk looks like. And milk has water, so these black dots are going to be water molecules, all right? I'm going to have to start using different colors now. There's water molecules all over all around milk. And then there's also protein. So I'm going to make the protein red circle. So I have big protein molecules, and those protein molecules are clumped together. See? But you see, with the colloid, the protein molecules are everywhere. They're not just on top or just on the bottom. They're everywhere. And then with the protein molecules, there's also fat molecules. So fat molecules, this purple or blue stuff is the fat molecules. So this is milk, protein and fat in clumps. The clumps are so small you can't see them. When you look at a cup of milk, let's say this is water. When you look at a cup of milk, it looks all the same. It looks all white. If it's homogenized milk, then it's all white, and this is just the water. So homogenized milk, I should have said homogenized milk. Homogenized milk is a colloid, meaning it looks all the same. If you leave it on the table, it doesn't unmix. As long as it's milk, it stays all white. The particles inside are so big you cannot see right through it. If you mix a little bit of milk in a lot of water, you could see through the water, but it's cloudy. It's not perfectly clear, so it's still a colloid. One drop of milk in a whole bunch of water, it's still a colloid because these fat and protein clumps will always be clumps. They will not be separated one molecule at a time the way you have in a solution. So that's a colloid. Now suppose, let's look at the heterogeneous mixtures. Oh, I forgot to write here. Among the heterogeneous mixtures, there are suspensions. And then there are just heterogeneous mixtures, other. Right? Let me give you an example of a suspension. If we take this milk here, I wonder if I can copy and paste the whole picture. See. Oh, yeah, I can. All right. So if you take this milk, and let's say it's not homogenized milk. Let's say I just milked the cow 5 minutes ago. And then I put this cup of milk on the table for a long time. And the cream will separate out and form a top layer, all right? So now, this is cream on top, all right? This is cream. Now I have a top layer which is different from the rest of the liquid. See, in the colloid milk, there's protein and fat on top, protein and fat on the bottom. It's the same throughout. But in this milk with cream on top, there's cream on top, but no cream on the bottom. So this is not a colloid. This is a heterogeneous mixture. This is other. It's a heterogeneous mixture because you can see the different parts. You can see just with your eyes that this substance is not one substance. It's actually two substances, cream and milk. That's why it's a heterogeneous mixture. Now, what is a suspension? If you have kids or if you've ever given medicine to a baby, you know that the medicine comes in the form of an oral suspension, like this. Look at that. These guys are oral suspensions. So here, let's see if I can get a picture. Yeah, like that. Look at this picture. See, this is a grape-flavored oral suspension. Look at this. Can I make this bigger? Yeah. You see that? Can you see through this purple stuff? No. You cannot see through this purple stuff. This purple stuff is quite milky. If you had some infant's Tylenol at home and you looked at that real closely, you could see little dots of Tylenol, solid Tylenol medication, little tiny dots of Tylenol powder floating around in this purple liquid. That's called a suspension. This is called a suspension because you need to shake the bottle in order to mix everything evenly. It looks all purple right now, but if you leave this syringe on the table for a long time, all the Tylenol solids are going to sink to the bottom, and you're just going to have purple syrup on top and Tylenol solids in the bottom. You try to give that to the baby, that's not going to go over too well. You need to shake this bottle. If you pull out or pour out Tylenol for babies and you didn't shake the bottle, then you're either going to have too much solid, you're going to overdose the kid, or you're going to have too little solid, and you're just going to give the kid this sugary purple syrup without the Tylenol. So that's what a suspension is. A suspension is a heterogeneous mixture which is made of particles that are so large that if you shake, if you leave the container alone, those particles will settle out. Right? So this is an example of a heterogeneous liquid. The solid dots are the solid, and these circles are the water molecules or the liquid. Right? So there's solid dots only on the bottom. That is a heterogeneous mixture. When I shake this up and down, I will have an even mixture of solid dots and water molecules, but that will be a suspension. Why is it a suspension and not a colloid? It will be a suspension because, number one, if you leave it alone, it will separate out. And number two, the particles, these solid particles, are so large you could see them. Just like in Tylenol, you could see those particles. Now, let me give you another example. Orange juice. This is my orange, and I juice it. And this is my pitcher of orange juice. All right? What happens to orange juice if you leave it there? Leave it on the table for a long time. Let's say you leave it there for 2 hours. It'll still be juice. It'll still be orange juice. However, you'll see that it's yellow and thick on the bottom and kind of orange, but you could almost see through it on top. That means that orange juice is a suspension. The particles, the orange particles, are so large that they don't stay mixed the way milk does, the way homogenized milk does. They separate out. And because they separate out, this is a suspension. It's not a colloid, it's not a solution, it is a heterogeneous mixture, which is a suspension. Not all suspensions are all suspensions are heterogeneous mixtures, but not all heterogeneous mixtures are suspensions. Like milk with cream on it, that's a heterogeneous mixture, and it is not a suspension. If you shake this a lot, I'm not sure that, I guess if you shake milk with cream on it a lot, it could become a suspension, but just for a moment. I'm not sure. I think technically you could call that a suspension. I won't ask a quiz question as so tricky as that. But most liquid suspensions, you just leave, you shake them, and then it looks evenly mixed, but then you leave it there, and then the different parts separate out. So air can be a suspension also if you have two different kinds of air in a room. So if you have a whole bunch of carbon dioxide for some reason in the room, and you blow a fan, so this is the fan in the room, and this is carbon dioxide, you blow it all around, yeah, it will be evenly mixed. But if you turn off the fan and you close all the doors and nobody moves in this room, then the carbon dioxide will eventually sink to the bottom, and you'll have a bottom depth of carbon dioxide and then no carbon dioxide on the top until the air gets disturbed again. So air can also form a suspension. Usually there just isn't enough carbon dioxide in a room to make such a suspension. So those are the drawings that you have to learn to recognize and perhaps to draw. Element, compound, solution, colloid, suspensions. I'm not going to ask you to draw these simple things. I'm going to ask you to draw mixtures of these things. And here's what I mean by that. I'm going to ask you to draw, I already have that, sorry. I'm going to ask you to draw something like the following. Oops. Right. So For example, I may ask you to draw a solid plus a gas in which the solid is made of a pure compound and the gas is a solution. All right? I'm going to ask you to draw something like that. And as a response, you will draw on a piece of paper a box. And inside that box, you will draw a solid, which is made of a compound. So not just one kind of circle. It has to be two kinds of circles like that. And they have to take up they have to hold their own volume, meaning you do not fill your box with it. And they have to have their own shape, meaning you do not cover the floor with it. So there's a solid. It's a compound. And the gas is a solution. That means there's a gas up here. It fills the entire container. It doesn't just fill the top, all right? It fills the entire container, around the solid, everything. Just not in the solid. But you see, it's a solution. So you cannot just have one kind of dot. You have to have two kinds of dots. Here's an example. All right? Everywhere, evenly mixed. A solution is evenly mixed. All right? So that would be it. I have just drawn here a solid right here. So then you'd have to label it. So this is the solid, like that, right? And this is the gas. And this is the solution. That's the solution. And this solid is the compound. It's pure. I'll put pure compound. All right? You got that? I'm going to ask you to do a lot of these things. All right? Well, not a lot. Just a couple. So try it out. Okay? Try it out, and then if you have questions, you can work with other people. That's fine. If your answer looks like theirs, that's also fine. But you need to understand this, because I'm going to put this on the next quiz that you'll take next week with Dr. Valdez, and you'll have to do that on your own. So this is something that you have to understand. Let me know if you have questions. Just find me by email or come to office hours. Thank you. Bye.